From the simplest microorganisms to insects and humans, all living beings follow a basic rule. They're born, they grow, they age, and eventually die. This was the rule until one species decided not to follow it. And while you may expect me to be talking about some obscure microscopic bacterium or a simple fungus in the middle of the earth, it's actually just the common lobster. From birth to death, lobsters just keep growing. Their cells don't seem to age, and they keep dividing, showing little to no signs of breaking down. And you guys need to understand, this goes against fundamental laws of biology and nature itself. Every cell that's ever been made is supposed to grow old and die. How is it possible that lobsters don't age? Why is it that out of all animals, the universe decided lobsters would be the ones to live forever? And what actually happens if a lobster lives too long? In most animals, aging is built into the system. Cells divide, wear down, and eventually stop working. Muscles weaken, organs slow, and the whole machine winds down. Remember Scarface, the legendary lion of the Masamara? In his final words, he was slow, frail, and clearly worn down. But no one who ever saw him go down like this would ever forget that he once was a beast who had taken down over 400 hyenas and killed more than 130 rival male lions. That decline, that visible weakness, that's aging. But a 90-year-old lobster grandpa could still beat a young one. What first caught scientists' attention to this trend wasn't a single lobster, but a pattern. Researchers who were studying lobsters began noticing that older lobsters didn't seem weaker than younger ones. And in fact, many older lobsters were larger, stronger, and more fertile. This obviously didn't line up with how aging normally works in literally any other animal. So naturally, scientists started asking, why aren't these lobsters slowing down? Just when they were about to lose their minds over it, it turned out lobsters produce an enzyme called telomerase, not just when they're young, but throughout their entire lives. That's unusual. In most animals, telomerase activity shuts down in adulthood, and they start aging. Let me explain in simple words. See, every time a cell divides, the tip of its DNA strands, called telomeres, gets shorter. When telomeres get too short, the cell can't divide anymore. That leads to aging, cell damage, and eventually death. Kind of like plastic tips of shoelaces. Once they weigh out, everything starts to unravel. But telomerase keeps those tips intact, meaning lobster cells keep dividing cleanly and efficiently. No breakdown, no DNA fraying, no slow crawl towards cellular death. In lab tests, scientists found that lobster tissue shows little to no signs of aging, no matter how old the lobster is. That's why you'll sometimes hear people saying lobsters are immortal. They're not actually, but the phrase comes from a real idea. Their bodies don't age like ours do. Their fertility doesn't drop. Their organs don't shut down. They don't get age-related diseases the way mammals do. From a biological standpoint, they could, in theory, just keep going. They can't actually die of old age. And if you remove predators, disease, and accidents, and lobster dinners on Friday, theoretically, lobsters could actually live forever. So what exactly brings them down, if not old age? It's a little weird, but lobsters kind of cement their own fate. Lobsters have a hard outer shell called an exoskeleton. This shell protects them from predators and physical damage. But here's the catch: a lobster shell is dead. Lobsters can't grow inside it. To get bigger, they have to shed it completely in a process called molting. Molting is like taking off a tight suit and growing a new, bigger one underneath. As lobsters get older and larger, molting becomes harder and more taxing on their bodies. Their shells grow thicker, making it tougher to break free. If a lobster fails to molt properly, it can get trapped inside its old shell, leaving it weak and vulnerable to disease or predators. Plus, molting requires a huge amount of energy. But funny enough, the same molting process is also the only time lobsters can mate. During mating, the male deposits sperm into a special pouch inside the female's body where it can be stored for months. She stays in his den for up to 2 weeks while her new shell hardens. Once her new shell hardens, she leaves, and in about 9 to 12 months, a mature female lobster can release around 100,000 eggs at once. No nest or protection, just a drifting cloud of life, most of which will disappear. Sounds like a booming start to life, right? Not exactly. Out of all of those eggs, less than 1% survive. The rest are picked up by predators, swept away by currents, or simply never make it. And from this strange and risky beginning, a rare few will grow into these crustaceans that never seem to age.